say they are affected by extreme temperatures. Also, we discussed functions of proteins where we say that they are used to produce the body with energy in cases of extreme starvation. We also went ahead and said that proteins can also be used to form structures of some animal parts or of body parts. Like for example, we have nails, we have hair, and we said we proteins are also used in so today I want us to talk about lipids. Okay, so we talk about lipids, we see what lipids are, and then we will continue and talk about something else. So lipids, in general, lipids are fats and oils. Now, if you're sure, if you know the difference between fats and oils, you will know that we get fats from animals and we get oils from plants. So we don't find fats in plants, we find fats in animals. That's why we say that chicken or that beef or that pork is fat. That pig is fat. It has a lot of fat. We don't say that that beef has a lot of oil. We say that beef has a lot of fat. So therefore, fats are found in animals. There's also a word that is used by people that I don't like using. We say, I'm getting fatter or I'm getting thinner, showing that we gain fats. So animals have fats, plants have oils. That is one difference. Okay. Now, mostly fats exist in solid form. Fats exist in solid form, while oils exist in liquid form. That is why you can have avocados producing oils. Ndio maana unasikia kuko na avocado oil, kuko na corn oil, kuko na maybe macadamia oil. We have nuts producing oils, coconut oil. So anything that is plant can only produce lipids in form of oils, and anything that is an animal produces lipids in form of fats. So with that, I'm sure we can of course, now in an exam you can get a question asking you distinguish or differentiate between fats and oils. So you draw a table and then on one side you write fats, on the other side you write oils. On the side where you have written fats, you say fats are solid at room temperature, while oils are liquid at room temperature. At room temperature, fats are solid, oils are liquid. The other difference would be fats are found in animals, while oils are found in plants. Fats are found in animals, while oils are found in plants. That's another difference. So now, let us look at the building blocks of lipids. What makes lipids? Now, if you remember, when you talked about carbohydrates, we said the smallest form of a carbohydrate is monosaccharide. And therefore, we said the building blocks of carbohydrates are monosaccharides. So, because you cannot break down a carbohydrate into any simpler form apart from a monosaccharide. We also went ahead and we said today that the building blocks of proteins are amino acids, meaning the smallest form of a protein, is an amino acid. So therefore, what are the building blocks of lipids? The building blocks of lipids are fatty acids and glycerol. So if you break down an oil or a fat, you will get fatty acids and glycerol. Fatty acids and glycerol. Now, what do we call the bond that combines a fatty acid and a glycerol? That bond is known as ester bond. Ester bond, E-S-T-E-R bond, ester bond. Okay, now if you remember very well in the morning we said the bond that combines amino acids or that binds two or more amino acids is known as a peptide bond. And then the one that combines that joins monosaccharides, we said it's a glycosidic bond. So it is very important that you know. Something which is not changing across all the types of food substances is when you combine the simplest forms of whichever substance, you combine them through a process known as condensation. And when you're breaking them down, the process still remains to be hydrolysis. So tuseme kama tuko na fatty acids and glycerol, tumezicombine, they form due to the process of condensation. Now, if you want to break down a protein into fatty acids and glycerol, we call that process hydrolysis. Like for example, what I have illustrated here. So in this illustration, we have a glycerol. So we have one molecule of glycerol, which is combined to 3 fatty acid molecules. So in lipids, one glycerol molecule combines with 3 fatty acids molecules. Combines with 3 fatty acid molecules. Okay, so we have that one as the glycerol, and then we have 1, 2, 3 fatty acid molecule. When they combine together, they combine through a process known as condensation. Okay, condensation is when we have a glycerol molecule combining with fatty acids to form a triglyceride or a fat, or it can even be an oil. If you want to break down an oil into fatty acids and glycerol, you do that through a process known as hydrolysis. No wonder the arrow is pointing backwards, but then to form an oil or a fat using fatty acids and glycerol, the arrow is facing forward, and that process is known as condensation. So it is very important that you get to note that. Good. With that, I believe we have gotten an idea of what lipids are, and you can be able to answer a question or two on what lipids are. So at this point, I don't know if there's a question on what we have learned so far. So if there's no question, then I think we can proceed to what is next. So no question. That means we are well understood. Good. Properties or characteristics of lipids. What characteristics do lipids have? Now, characteristic number 1 of lipids is that fats readily and easily change into liquid when heated, while oils solidify when subjected to low temperatures. That is a straightforward thing. Ukiweza kuwa na mafuta ya oil, okay, alafu iweke mahali kuna baridi sana kama kwa fridge ama uiweke kwa floor, hiyo mafuta huwa ina solidify, inakuwa solid. In as much as we have said oils exist at room temperature in liquid form, when exposed to extremely low temperatures, they solidify or they become solids. Again, if you take fats at room temperature, they are solid in nature. But if you heat them, especially like when you're cooking, you see it melting. That is why we are saying one of the property or one of the characteristic is that a fat can easily be heated into oil, while oils can be solidified into solid state. That is one property or one characteristic. The other characteristic is that fats are insoluble in water. They are insoluble in water. No matter how much you try to dissolve oil in water, at the end of it all, the water will settle down and the oil will settle at the top. So mafuta yote huwa inalea juu, it is going to settle at the top of the container, while all the water settles at the bottom. This is because oils have, or fats have, when they are, of course, when they are melted, they have a lesser density compared to water. That is why oils or fats do not dissolve in water. However, they dissolve in organic solvents, forming emulsions or suspensions. Now, we give examples of organic solvents. One example of organic solvent ni alcohol or ethanol. So if you have ethanol and you dissolve fats or oils in ethanol, they will dissolve in that particular organic compound. So in an exam, usually we say fats and oils or lipids are insoluble in water but are soluble in organic substances or solvents such as ethanol. So ukiweza kuwa unaweza pata access ya ethanol uchanganye na mafuta, of course you will see that ethanol is going to dissolve the lipids. Okay, so that is the second characteristic. The first characteristic tulisema ni ile ya change from liquids to solid. The second one tumesema they are insoluble in water. The third property of lipids is that they are inert. When we say something is inert, we mean it does not react easily, so therefore it can be transported in a variety of containers. Like for example, you would never transport acids using metallic containers. Hata zile plastic ama hata zile containers zinabebanga acids, all of these containers, they must be made of plastic. Why? Because acids do not react with plastics. But when you expose an acid to a metal, there will be a reaction between the acid and the metal. When you talk about lipids, on the other hand, they do not react with metal, they don't react with wood, they don't react with plastics. So lipids can be transported in any container. Ndio maana unaweza enda kununua mafuta kwa duka uwekewe kwa karatasi ya nylon. Saa zingine uende na kakibuyu uwekewe. Saa ingine kakibuyu ya metallic uwekewe. So it doesn't matter. Hata uweke kwa chupa ya glass, but that oil will never, or those fats will never react with the container. So therefore we say lipids are inert. What is the advantage of lipids being inert? They can be stored in tissues of organs, and also they can be transported with any container, unlike other substances. So those are the properties of lipids, and in an exam you might be required to give the properties of lipids. So let's talk about the functions of lipids in animals or plants body. What are the functions of lipids in animals or plants body? Remember tulisema biology is a branch of science that deals with the study of plants and animals. So therefore, we cannot fail to state the importance of lipids in both plants and animals. Good. So the first function is that lipids are broken down to give energy. Now there's one thing I want you to note. Whether it is lipids, whether it is proteins, whether it is carbohydrates, all those food substances can be broken down in the body to release energy. However, it is carbohydrates that are mostly used to release energy in the body. The body ignores lipids and it also ignores proteins until it's a situation where your body is starving. So lipids can be broken down. Now in an exam, there's a very common question which asks you, I don't know if you can be able to write, kindly write down this question somewhere. Kindly write it down. The question is, write it down, tafuta mahali uandike. Why are lipids not used to produce energy in the body? Why are lipids not used to produce energy in the body? By the way, for your information, the type of food that can produce the highest amount of energy in the body, it is fats and of course lipids. So lipids are the ones that can give the highest amount of energy, more than carbohydrates. However, the body is going to use carbohydrates instead of lipids. Why is it so? There are very many reasons. I'm only going to give you one reason and then you will search for the other two reasons. So the first reason why lipids are not used in respiration is because they are insoluble. So lipids are insoluble, hence cannot be easily transported by the blood. Lipids are insoluble, hence are not easily transported by blood. So you can imagine blood is made of 70% water. So if we decided to use lipids for respiration to release energy, it would mean that the lipids are going to be transported by the blood, and since the blood cannot dissolve the lipids, itakuwa ina flow huko tu ndani ya mwili. And remember we said under low conditions, temperate conditions, they can change into solid state. So therefore unapata the blood vessels will start clogging due to a lot of lipids on the walls of the blood vessels. So there are very many other reasons, but I've only given you one, and that is the assignment for the day. You will look for reasons why the body does not use lipids to generate energy, but instead uses carbohydrates. So go do that research, and it is straightforward, you're going to get it. So functions of lipids, we're still continuing. So tumesema they can be broken down or they can be oxidized to release energy. Function number 2, they are storage forms of food in the body of living organisms. So that means lipids can be stored in the body. Lipids can be stored in the body. So the other function of lipids, they can be oxidized to release metabolic water. They can be oxidized to release metabolic water. Now, us as human beings or animals, any animal that you have ever come across, we have requirement for water. Animals require a lot of water. Now, which are the sources of water? The following are the sources of water. I hope you're listening. Sources of water in animals. Number 1, we have water from the feeds. You see the feeds an animal take? That feed can contain water. So for animals like maybe sheep and goats and cattle, when they feed on grass which is not dry, that grass has a lot of water which can be converted and used in the body. Same as human beings. When we eat vegetables, when we eat fruits like mangoes, those mangoes have water in them, the oranges and the rest. So when you drink when we eat the vegetables, we we take in the water. So therefore that is the first source of water in the body of an animal. The second source of water in the body of an animal, this source of water is through drinking. So when you kachupa ka water bottle and you decide I'll be consuming 1 liter of water per day, 1.5 liters of water per day. That is water from drinking. Okay? The third type of source of water in the bodies of an animal, these ones we don't even know we are producing it. What happens is, if the body is using lipids, to produce energy, the process of breaking down lipids to release energy produces a byproduct, which is water. So water is a byproduct of respiration when lipids are broken down. So if you have that water, you don't need to supplement or supply a lot of water to your body through drinking. But there are some people who will only get satisfied or quenched of thirst by maybe drinking water. But initially, there are 3 sources of water in an animal's body. Metabolic water, this is water that is produced when respiration takes place and lipids are broken down. And then we have number 2, we have water from drinking, and number 3, we have water from the feeds. When the animals feed on succulent or plants which have a lot of water in them, fresh plants, then they get water from the feeds. So therefore we are saying that lipids are broken down to release metabolic water in the body. Reason number 4, or we have function number 4 of lipids, is that lipids are components of plasma membranes and protoplasm. They are components of plasma membranes. The other name for plasma membrane is cell membrane. Now remember tulisema cell membranes are made of two protein layers, actually a protein layer, and then we have phospholipid layers. So those phospholipid, meaning there is a lipid layer, phospholipid, a lipid layer. So therefore, we can comfortably see that lipids form components of animals or plant structures, such as a cell membrane. Good. Number 5. Fats are deposited under the skin. They are deposited under the skin so that they can prevent heat loss. Now, I want you to think of a polar bear. I hope you know what a polar bear is. A polar bear is an animal that lives in the Arctic or in very cold areas. So those animals have one characteristic. They are very big. They are fat. Why are they fat? They are fat because in their body, there's a layer beneath or below the skin. You see the skin which you're touching? Below that skin, there can be a layer of fat. And that layer of fat, kila mtu ako nayo. Ndio maana saa zingine ukiweza jikata na kisu, kuna venye unajikatanga unaona umeona kitu ya white ndani. Usually hii inakuanga ni a layer of fat. And that layer of fat is very important because it guards the body against heat loss. It insulates the body. Like you see, for example, the way you use a aluminium foil to actually fold some food and to retain the heat inside the aluminium foil for a while. That is exactly how fats function. Because our bodies are surrounded by fats, those bodies are going to be insulated against heat loss. So ile heat yenye iko ndani ya mwili kama saizi kuna baridi, of course it will not be lost. So therefore, those animals that live in very cold areas store fats under the skin to insulate the body against heat loss. Okay, very good. The other function of lipids is that fats are deposited around body organs like the kidney, heart, or the eyeball, and they act as a shock absorber. I'm not sure if you have ever seen when you have ever slaughtered something like a goat, and in the process of slaughtering, or you've seen people slaughtering, you notice that pieces of the kidneys, the kidneys are surrounded by a layer of fat. The heart itself is surrounded by a layer of fat. Kabla ufikie roho, you have to remove some white fats which are on top of the heart. So they actually surround the major organs. The reason why our body's major organs are actually surrounded by a layer of fat is so that that fat can act as a shock absorber. In case umeanguka, the major organs are not going to be damaged because they have been cautioned. Ni kama venye uko na caution, ukiwa kwa nyumba na uko na caution, hiyo caution inakuzuia ufinywe na kiti. So the lipids or fats can be deposited under major organs, and actually they can act as shock absorbers to caution the particular body organ. Okay, yes, that's another function. So fats are deposited around body organs so that they can act as a shock absorber. So we have those as the major functions of lipids, and in an exam you should be able to answer questions on lipids. Now we are going to do some questions tomorrow. Kesho tutakuwa tunafanya questions za photosynthesis, alafu tufanye zingine za chemical compounds of life, so that we can actually be able to see if we comprehended what we have been doing. So far so good. I want to believe that we are understanding what we are saying. So just type for me. You don't have to say it, or if you want to say it, you can just open your mic and tell me if you have understood and if we should proceed to the next subtopic. So is the subtopic well understood? Of course, well understood means you have understood some concept which we will reinforce with many questions. So have you understood the chemical compounds of life, the 3 types of food substances, their functions and how they are made? If yes, just type understood kindly, or you can open your mic and say understood, so that I will get I'll get to move on to the next subtopic. So kindly feedback kidogo. on if you have understood chemicals of life or the chemical compounds of life. Feedback kidogo kindly.
Understood, mwalimu.
That's good. Domintila, understood?
Yes, teacher.
Catherine, understood? Catherine, are you with us? Catherine ni kama hayuko na sisi. She will type and tell us if she good. Thank you, Catherine, for confirming. Good. With those very many remarks on chemical compounds of life, let us move on to something different. Something which I'm usually always excited to teach about, because I know there are two things which we cannot survive without. Number one, hormones, and number two, we have enzymes. So I like teaching about hormones. I personally love learning about hormones and enzymes because they form a very important, or they play a very vital role in our bodies or even in plants for survival. And you're going to see how interesting enzymes can be. Now, what are enzymes? I remember today in the morning when we were talking about proteins, we mentioned something and we said that proteins form components of body structures or substances. For example, we gave hormones and we gave enzymes. So therefore, enzymes are actually catalysts which are protein in nature. Now, the first question here, what is a catalyst? A catalyst is like something which is used to speed up a process, exaggerate a process. Like for example, if you found your house burning, how would you switch off the fire in your house? A, would you use soil or water, or would you use petrol? Utamwagia nyumba petrol ama utatumia mchanga ama maji? Which one will you use to put off fire in your house if you found your house burning, God forbid?
Soil.
You will use soil or water, isn't it? Now, what happens when you add fuel like petrol or diesel? Ama mafuta ya taa?
Naongezea moto.
Yes, moto itaongezeka. So therefore we can say this oil is catalyzing. It is speeding up the rate at which the fire is spreading. So similarly in our bodies, metabolic activities or those processes that take place in our bodies, they are controlled or they are regulated by a protein known as enzyme. Okay? So enzymes hazitumiki kwa reaction yeyote. That is something which you should note. We do not have enzymes carrying out any reaction. Actually, enzymes speed up. That's why we say enzymes are organic catalysts that are protein in nature. Enzymes are organic catalysts that are protein in nature. Enzymes are organic catalysts that are protein in nature. So rule number one, point number one, they are organic, meaning they are synthesized in the body. Number two, they are actually protein in nature. They are made of proteins. What does that mean? Remember in the morning we said proteins are affected by extreme temperatures or extreme changes in pH. Meaning, kama pH imekuwa extreme, iko very acidic, we are going to destroy the enzymes. So enzymes do not do well in actually pH that is extreme. Another point to note is that since they are protein in nature, it also means they actually cannot survive in extreme temperatures because extreme temperatures denature enzymes or the protein in the enzymes. Okay, so when we say that enzymes are organic catalysts which are protein in nature, it means that enzymes, of course, they are affected by extreme temperature and extreme pH. Types of enzymes. How many types of enzymes are there? We have two Hey, sorry for that. My internet flicked out because there was like a power outage for like a second. So let me display this again. Sorry for that. So as we were saying, we were talking about enzymes na tukasema that there are two types of enzymes. Okay, we were talking about the types of enzymes. There are two types of enzymes. Now the first type of enzymes are intracellular enzymes, and then the other one we have intercellular enzymes. So you have two types of enzymes. The first one is intracellular, the second one is intercellular. Now what is the difference between what is the difference between intra and extracellular enzymes? Intra means from within, like the way we say intraspecific motivation. Intra ni internal. Like for example, if we have a cell, an animal cell, like a cell in the mouth, okay, and that cell produces an enzyme which is used within that cell. I don't know if you're getting it. We have an enzyme in the mouth. We have a cell in the mouth. An enzyme gets produced inside that cell and at the same time gets used inside that particular cell. Haitatoka nje ya hiyo cell. Then we say that is an intracellular enzyme. It is an enzyme that is produced and used within the cells that produce them. So ikitengenezwa kwa hiyo cell, inatumika hapo ndani kwa hiyo cell. That is an intracellular enzyme. Then we have extracellular enzyme. Extracellular enzyme. Now, extracellular enzyme is an opposite of intracellular. So, extracellular enzyme, it's an enzyme that is produced but used outside the cells that produce them. So, inaproduciwa kwa cell, lakini haitatumika kwa hiyo cell, inatumika huko nje. Let me put this in a layman's language, in a language that even a class 1 student will understand. Now, we all cook, or we all get cooked for those that don't cook. So if you cook food to consume in your house, that is intra-cooked food. Food which you have cooked and you have used that food and consumed it in your house together with your family. If in case you decide that I'm going to cook chapati, or I'm going to cook smoky, or I'm going to bake a cake for the purposes of selling, that is extra. It has been used outside. So the same thing, we can transfer it here. So when an enzyme is produced inside a cell and used within the same cell, that is an intracellular enzyme. If it is produced in a cell and used outside that cell, that is an extracellular enzyme. So a very good example of extracellular enzymes are the digestive enzymes. Enzymes which are used in the digestive system. Like for example, in your mouth, you produce saliva. Saliva is a mixture of very many things, which include water. It also includes mucus. It also includes an enzyme known as enzyme ptyalin or salivary amylase. Salivary amylase inatumika kwa mdomo ndani, lakini inaproduciwa na salivary glands zenye zinakuanga huku kwa mdomo. So hizo glands are cells that produce an enzyme like the salivary amylase, lakini haitatumika hapo kwa hiyo cell. Lazima ireleasiwe iende kwa mdomo, ndio mdomo iproduce ama idigest hiyo food. So therefore, we say that extracellular enzymes are enzymes which are produced in cells but are used outside those cells. Naming of enzymes. How will you name an enzyme? How do you name enzymes? Now, enzymes are named based on very many things, okay? Like for example, there is one method of naming enzymes which is known as trivia naming. Trivia naming. Now, trivia naming is basically a method of naming enzymes that involves naming the enzyme after the person that discovered that enzyme. Okay, if I am the one who discovered the enzyme, at the end of my name there will be addition of a suffix in. Okay, trivia naming involves naming an enzyme by placing a suffix in at the end of the name of the person who discovered that enzyme. Okay, so for example, if it is Nelson that discovered a particular enzyme, that enzyme will be named, if we follow this method, the enzyme will be named Nelson-in. Nelson-in, because it's the name of the person that discovered the enzyme, and then a suffix in at the end of it. So Nelson-in. But since I have not discovered any enzyme, we will work with those enzymes which have already been discovered. A very good example of an enzyme that was discovered by a person whose name was used to name that enzyme, it is an enzyme known as pepsin. Pepsin. So this enzyme was discovered by someone the name Pep something, and then at the end of it all, a suffix in has been added. So therefore we get enzyme pepsin. We are going to see where pepsin is used later on. Then we have renin. Renin, meaning the name of the person who discovered that enzyme has something to do with ren. RENN, something. It could be a short form or it could be the final name. But then at the end, there is addition of a suffix known as IN. That one. IN, IN, IN. So every time you hear the name of an enzyme and you discover that this name of an enzyme is ending with IN at the end of it, then it shows that that enzyme is named after the person who discovered it, and they have added suffix in at the end of the name of that particular enzyme. So I hope we are moving together. So now I want you to tell me, tell me, if you discovered an enzyme, what name would we give that enzyme following that method of naming enzyme known as trivial naming? So tell me, Domintila, let's begin with you. If you discovered an enzyme and we want to use that method of trivial naming to name it, what name would you give that enzyme using that trivial naming method? You take your name, that's the secret, and then you can give either the short form of your name or the full name, but at the end of it all, you use suffix in. So Domintila, which enzyme, if you discovered an enzyme and we decided to name it using trivial naming, which name would you give that enzyme using your name? Okay, looks like Domintila is not ready. Monica?
Domilase, teacher.
Yeah, sorry? Domilase. Domilase. We are saying trivial naming inatumia suffix in at the end. You take the name of the person who discovered the enzyme and then you add suffix in. So it cannot be less. It can only be domin. Yes,
Domin.
domin or dominin or domintilin, something like that, isn't it?
Yes.
Yeah.
Monica, if you discovered an enzyme, what name would we give that enzyme using that trivial naming method?
Monicaine.
Monicaine, good. We can also have monin, isn't it?
Yes.
Good.
Yes.
Catherine, if you discovered an enzyme and we want to use a trivial naming method, which name would we give to that enzyme? You'll type for us.
Catherine,
Just
I remove E from the end.
You remove E from the. So what name would you give it?
Catherine.
Catherine or Kathleen, isn't it? Whichever you want to give, so long as there's your name, either abbreviations or the full name, alafu mwisho kuko na IN, isn't it? Very good. And that is how we use trivial naming. That is how we use trivial naming to name enzymes. So I hope that is understood, and we can move to the next method of naming an enzyme. So apart from trivial naming, the other method of naming enzymes can be use of suffix "-s". Now, in English, there are two things. The first one is a suffix and a prefix. Prefix comes before, prefix. Suffix comes after. Now, instead of using suffix "-in", in the second method of naming enzymes, we have use of suffix "-ase" at either the end of the food substance that is being broken down. Like, for example, if we have carbohydrates being broken down, we can have an enzyme known as carbohydrate, we say carbohydrase. So ukiangalia vizuri, what has happened here is that we have added suffix "-ase" at the end of the name carbohydrate. So this is showing the food substance that is being broken down. The food substance is a carbohydrate, but the name of the enzyme is carbohydrase. So what has happened? We have added the suffix "-ase" at the end of the food substrate being broken down. Another example is amylase. So when we have the food substance amylase, this should be A, not O. When we have the food substance amylase, it is broken down by an enzyme known as amylase. Okay, so we have amylase being broken down by amylase. Then we have sucrose. Sucrose can be broken down by an enzyme known as sucrase. So what are we doing? We are adding an enzyme "-ase" at the end of that particular food substance. The other one is maltose. Maltose is the food substance, if you remember very well, tulisema that's a carbohydrate. So maltose, of course, is going to give an enzyme known as maltase. Proteins, if they get broken down by an enzyme and you want to name an enzyme after the food substance being broken down, then we can have the name of an enzyme known as protease. So what have we done? We have added "-ase" into the mix. Higher. Then we have lipids. So lipids are broken down by an enzyme known as lipase. So what have we done? We have taken the name lipids, tukaigawanisha ikakuwa lip, alafu tukaongeza "-ase". So therefore the enzyme becomes lipase. So you can add suffix "-ase" at the end of the food substance being broken down. So that's another name, another way of naming enzymes. On the same, instead of using the food substance that is being broken down, you can actually name an enzyme based on the reaction type that is taking place. Like, for example, we have reactions which are known as hydrolysis. Kumbuka tukisema kuhusu chemical compounds of life tumesema that you can break down a complex food substance into a simpler food substance through a process known as hydrolysis. For example, When we have two amino acids combining to form a dipeptide, then that amino acid can be combined through condensation. When you take that dipeptide and you want to break it down back to their constituent amino acids, then we say that that reaction is a hydrolysis. Another example, when you have two amino acids combined together, not amino acids, I mean monosaccharides combined together, they form a disaccharide. So when you want to break down a disaccharide into monosaccharides, you break it down through a process known as hydrolysis. So the reaction taking place here is hydrolysis. So we take the reaction which is hydrolysis, and then we add a suffix ase at the end of that particular reaction. So then therefore we are going to have hydrolase. We are going to have hydrolase. So chemical reaction is hydrolysis. The enzyme is hydrolase. Hydrolase. The other reaction which can take place in the body or in plants is oxidation. Oxidation actually basically means addition of oxygen. Okay, like for example, you see when food substances are being broken down to release energy in the body, kama tuseme umekula ugali, ugali na digestiwa inakuwa carbohydrate, inakuwa glucose. Hiyo glucose ndio ibrekiwe down kwa mwili i-release energy, inakuanga released through a process known as respiration. Respiration takes place in presence of oxygen. So without oxygen, respiration hardly takes place. So ndio ile food substance ulikula ikuwe broken down to release energy, it has to be broken down through a process known as oxidation. Oxidation means addition of oxygen or breaking down in presence of oxygen. Okay, that is the meaning of oxidation. Good. Then from there, the type of enzyme that we can get from there ni oxidase, from the word oxidation. So the enzyme is oxidase, from the word oxidation. If a reaction involves reduction, then the enzyme will be reductase. So you can add suffix ase either at the end of the food substrate that is being broken down, or at actually the type of reaction taking place. And that is how enzymes should and can be named. So it all depends on the person who wants to name the enzyme or who is naming the enzyme. They can decide to use trivial naming, or they can use the suffix ase at the end of the food substance that is being broken down, or the type of reaction that is taking place. Now basically those are enzymes. So I repeat, let me go through it again. Enzymes are organic catalysts which are protein in nature. Then we have two types of enzymes: intracellular enzymes and extracellular enzymes. Intracellular enzymes are enzymes which are secreted and used within the same cell. But if the enzyme is going to be actually produced and used somewhere else, then that one becomes an extracellular enzyme. Then we have talked about the naming of enzymes. So we've said we have trivial naming. This is where an enzyme can be named using the name of the person that discovered it by adding suffix in at the end of that name. And then of course the other method of naming enzymes is using suffix ase at either number one, the end of the food substrate that is being broken down, or the chemical reaction that is taking place. Those are ways of naming enzymes. Now, what are characteristics of enzymes? Characteristics are the same as properties of enzymes. Properties of enzymes or characteristics of enzymes. The first characteristic or property of an enzyme is that they are affected by changes in temperature. Why will enzymes be affected by changes in temperature? The main reason why enzymes will be affected by changes in temperature is because, remember pale kwa introduction tulisema enzymes are protein in nature. meaning that those enzymes are made of proteins. And remember tulisema proteins are denatured or destroyed by extreme temperatures. So therefore, enzymes are affected by changes in temperature and pH. That is the first property. And this is a highly examinable area, by the way. So number 2, enzymes are substrate specific. What is a substrate? A substrate is a type of food substance. A substrate is a type of food substance. Examples of food substances ni carbohydrates. Okay, carbohydrates. Another food substance example ni lipid. Okay, lipid. Another food substance ni proteins. So a substrate is a food substance. So what do we mean when we say that proteins are substrate specific? Enzymes break down ama they accelerate. Tumesema they are catalyst. They accelerate breaking down of specific food substrates. Kumaanisha, if an enzyme has been produced to accelerate the digestion or the breakdown of proteins, that enzyme cannot function in presence of lipids. Neither can it function in presence of carbohydrates. That's why we're saying enzymes are substrate specific. Kama imereleasiwa na imeproduciwa kwa mwili idigest ama isaidie kudigest proteins, it will only digest that. So it makes no sense of an enzyme being added to a food substrate that enzyme does not break down. So therefore, that's why we're saying enzymes are very substrate specific. They only digest or break down food substances which they are meant to. Okay, good. Let us talk about the third property of enzymes. So the third property or third characteristic of an enzyme is that they are very efficient, hence required in small quantities. Enzymes hazihitajiki mingi kwa mwili, kidogo tu imetosha. So that is why even when you're eating food, the amount of saliva you produce cannot be enough kwa ile chakula kukua it is completely soaked in saliva. But even that little amount of saliva that is produced, it has enough enzyme that is responsible for breaking down proteins in case you are eating a food substance that has proteins. So therefore, they are very efficient. So therefore, they are not needed in large amounts. They are only needed in small amounts, and that is the reason why they are produced in very small amounts. The reason, the property number 5 or characteristic, remember properties are the same as characteristics. So characteristic or property number 5 is that enzymes have reactions which can be reversed. Most of the enzyme controlled reactions are reversible. For example, if an enzyme is used to break down a disaccharide into a monosaccharide, that reaction can be reversed such that tunaweza combine zile carbohydrates, zile monosaccharides back into disaccharides. So hakuna permanent reaction taking place that is catalyzed by enzymes. Most of the enzymes break down food substances through they assist in breaking down that food substance, but that food substance can be actually reversed back into the original food substance. So therefore, that is where we are saying that most of the reactions catalyzed by enzymes are reversible. So in an exam, this question is highly examinable. So utapata kwa mtihani umeambiwa list 3 properties of enzymes, list 2 properties of enzymes, list 4 or even discuss 4 properties of enzymes. You should be able to give those properties, which include they are affected by changes in temperature and pH, they are substrate specific, meaning they only break down a specific food substance, and then they are required in very small amounts since they are efficient. And then of course we have they are not affected by reactions they catalyze, and most reactions catalyzed by enzymes are reversible. They can be reversed back. Very good. So now we have what are enzymes. Okay, then we have the types of enzymes which we have learned. Then we have properties or characteristics of enzymes. And then we have talked about how we name enzymes. So I want to believe we have all understood that. So that we will talk about the last one, importances of enzymes. And from there, we will see what affects enzymes and the reactions they catalyze. Okay, so what are the importances of enzymes? Importances of enzymes. They control and regulate reactions in the body. So if you have enough enzymes, most of the reactions will take place. If you do not have enough enzymes, the reactions are going to take place, but at a very slow rate. Then we have enzymes. This is the reason why we need enzymes. Enzymes are required so that every reaction that is taking place in the body can be regulated. Alafu tumeambiwa NB, the speed of enzyme catalyzed reaction is known as turnover. Okay, enzyme turnover. So meaning kama tuseme imehappen haraka tutasema the turnover is high. Kama imehappen polepole, the turnover is low. So enzymes are very important because they catalyze the reactions which are taking place in the body cells and in the plant cells. So those are enzymes in a nutshell. The only thing that is remaining for us to look at is factors affecting enzyme controlled reaction. Factors affecting the reactions. Now, before we do factors affecting enzyme controlled reactions, I'm thinking we do several questions, because the concept of enzyme controlled reactions and factors that affect enzyme controlled reactions, that content is a bit complex kidogo, but it is easily understood. I will explain. I'll make sure I explain it until you understand it. But in the meantime, why don't we do some few questions from ile part ya photosynthesis hadi penye tumefika saa hizi, ndio tukifanya hayo maswali at least it will jog our mind, na ndio tujue kenye tumefanya for that time na kama tumeielewa. Okay, so we are going to do some study questions on that. Study questions. So allow me to look for study questions from that. Give me a minute so that I can look for questions on nutrition. Now, I have displayed some questions here. Let us look at some questions which are related to the part which we just did. Good. Question 7. We are looking at question 7. The chemical equation below represents a physiological process that takes place in living organisms. Represents a physiological process that takes place in living organisms. Now let us break down the question together. We break down the question together. Ukiangalia vizuri hapa utaona we have number 1, we have C6H12O6. C6H12O6. Now if you look at that, if you divide everything there but by 6, utapata itakuwa CH2O. Na ukikumbuka vizuri kwa food substance zenye tulikuwa tunasoma chemical compounds of life, you will see tulisema carbohydrates are made of carbon, hydrogen and oxygen in the ratio of 1:2:1. So ukiweza divide hii 6 divide by 6, it will be 1. 12 divided by 6, it will be 2. And then the 6 on the O, you divide it by 6, you'll get 1. So therefore that is the carbohydrate. Which type of carbohydrate is this? Ukiangalia vizuri utaona this is actually glucose and the other one is glucose. And then it is going to form something known as C12, H22 and O11. So that's a more complex type of a carbohydrate. Okay, so therefore which process is this? Hii process inaitwa aje? Process yenye unachukua monosaccharides mbili and you combine them to form a disaccharide or a polysaccharide.
Condensation.
Condensation. Very good. That is very good. The answer is condensation. Now when condensation has taken place, what is the other substance that is formed apart from a disaccharide?
Water.
Water. So therefore, the substance Q is water. So hiyo ilikuwa rahisi, like you have seen. So we look for another question. Maswali hayakuangi magumu. Another question. So I'm looking for a question, another question. I see if I can get a question. Looks like maswali ni ya Menda nutrition in animals. Bado tujafika huko. Most of them are photosynthesis. Let me look for another set of questions. Give me a minute. Another set of questions. So in these sets of questions, tumefanya question 1, imekuwa repetition. Good. Question 6. Question 6. Question 6 is a very, very good question. Higher. Let me read for you. The diagram below shows chemical reactions A and B, which are controlled by enzyme X and Y. A and B controlled by enzyme X and Y. Let's break down this question. We break down the question. So in this question, we have the first section here. We have glucose plus fructose. Hii ni carbohydrate. And remember tulisema glucose and fructose are monosaccharides. So when you combine two monosaccharides, you form a disaccharide. Glucose and fructose, through this process or reaction A, it will give you hii kwa hapa chini, which is sucrose and water. So fructose inapitia hii process yote inakupea sucrose and water. So the question is, what do we call the process through which glucose and fructose are combined to form sucrose and water?
Condensation.
Condensation. So we can all agree it is condensation, isn't it? Good.
Yes.
Then we have the same substance which are formed here, sucrose and water. They can be actually broken down into constituent monosaccharides. Now what do we call this process B? Hii process yenye inafanya sasa sucrose inakuwa broken down back to glucose and fructose.
Hydrolysis.
Good. So we can all agree it is hydrolysis. Yes, so it is hydrolysis. Now, what the first question is name reaction A. So reaction A tumesema ni condensation. Then we have reaction B. Reaction B, we have hydrolysis. Tuko na hydrolysis. So the question is, hydrolysis imetumia nini? Maji to break down sucrose into glucose and fructose. Which enzyme is likely to break down sucrose back into fructose and glucose? Remember, when you're naming enzymes, you can name an enzyme by adding a suffix ase at the end of the name of the food substrate that is being broken down. In this case, we have sucrose being broken down into glucose and fructose. So which name can we give using the food substrate that is being broken down and adding suffix ase? The name of the enzyme is going to become
Fructose.
yes. So nimesikia answers mbili. Nimesikia mtu amesema fructose na nimesikia mtu amesema sucrase. Tunatoka hapa kwa sucrose tunaenda back to fructose. So between sucrase and fructose, which name which answer is the correct one?
I think mine, sucrose.
Sucrase, because it is ASE, So we can agree it is sucrase. Sindio, Monica?
Yes, sir.
Yes, it is sucrase. Catherine, we can agree it is sucrase, because it is. So ni hii sucrase inakuwa broken down, ama ina break down sucrose into glucose and fructose. However, that is one possible answer. We can also have another answer. Do you know what I'm saying? We can also have another answer. It is because the process of breaking down sucrose into glucose and fructose is known as hydrolysis. And we can have an enzyme name based on the type of reaction that is taking place, isn't it? So the reaction type here is hydrolysis. So what would be the name of the enzyme if you decided to use the type of reaction taking place?
Hydrolase.
Hydrolase. The answer should be hydrolase. So we can all confirm that the answer should be hydrolase. So if in case it's an exam umepeana hydrolase, well and good. If you have given sucrase, it is also well and good. So that question is well understood and well answered. So I think we can confidently move on to something else, isn't it? So we look for another question that is related to what we have done. Let me see. I have found a question. Question 21. This one we talked about in the morning. So question 21. A solution of sugar cane was boiled with hydrochloric acid, cooled, and then sodium hydrogen carbonate was added. Hiyo hata si ni story mingi yenye sitaki tuongelelee for now, kwa sababu we are yet to do a practical question on test for these substances. Okay, now yesterday the last time we had a lesson on carbohydrate, and still today in the morning I mentioned, tulisema if you boil any complex carbohydrate in an acid, the carbohydrate is going to be hydrolyzed or broken down into its simplest form. Si ndio? Tulisema hivyo?
Yes.
Now, who is remembering, who can remember the type of carbohydrate that is found in sugar cane? Give me the type of carbohydrate which is found in sugarcane. Tip or hint, it is a disaccharide. Starts with letter S.
Sucrose.
Sucrose. The answer is sucrose. So, ile miwa yenye unakula iko na type of carbohydrate which is a disaccharide known as sucrose, isn't it? Now, when we boil sucrose in hydrochloric acid, what will happen to sucrose? Will it remain sucrose?
No.
It will be broken down into constituent monosaccharides. Itakuwa hydrolyzed to zile carbohydrates ama monosaccharides zina form sucrose, isn't it? Zenye ni gani na gani? Which monosaccharides combine to form sucrose? One of them, of course, is glucose. Glucose plus glucose
Fructose.
plus
Fructose.
yes,
Fructose.
it is plus fructose or fructose. Now, let me take you back through that process. I remind you again. When you combine glucose and glucose, you get a disaccharide known as maltose. It is important if you wrote that somewhere because you should not forget. So when you combine glucose and glucose, you get maltose. Glucose plus glucose gives you maltose. Glucose plus fructose. Glucose plus fructose gives you sucrose. And sucrose and maltose are disaccharides, while glucose and fructose are monosaccharides. When you combine galactose plus glucose, you get lactose. When you combine galactose plus glucose, you get lactose. Now, lactose is a disaccharide, while glucose and galactose are monosaccharides. So, in an exam, you can get such a question. So, why was the solution boiled with hydrochloric acid? Tuachie hapo kwanza. Why was the solution boiled with hydrochloric acid? Anyone? Why was sucrose boiled in hydrochloric acid?
To reduce the amount of glucose.
To reduce the amount of glucose? That's a very good answer. A very good answer, to reduce the amount of glucose. Catherine, do you have an answer on why we're boiling the sucrose in hydrochloric acid? Catherine, are you there? Monica, do you have an idea? Okay.
Tell me.
Sorry?
You said that it will reduce the amount of glucose. It will reduce to monosaccharides.
To monosaccharides. Good. It is true. Those answers are correct. But we do not say to reduce. We say to break down. Okay? Or to hydrolyze. The correct word is to hydrolyze. Sawa? So the only wrong thing with that answer ni ati tumesema to reduce. But the answer is correct. But the answer should be to reduce. I mean to hydrolyze, sorry. So the reason why sucrose was hydrolyzed in was boiled in hydrochloric acid is to hydrolyze it back into glucose and fructose. Very good. I will look for another question. Good. Question 28. Question 28. What is the fate of excess glucose in plants? We did that the other day. Glucose ile iko excess, fate yake ni gani? What happens to it?
It is converted into starch.
it is converted into starch. Good. Haya. Sasa, I want someone else to answer the next question. What is the fate of excess glucose in animals? Yeah, plants tumepata, umepata, that's good. It is converted into starch. So what is the fate of excess glucose in animals?
It is stored as a glycogen.
Very good. It is converted or it is stored as glycogen. Hey, biology mnaiva. You are getting it. You're getting the concepts. I'm happy. I'm very happy for you
Because we
guys.
are a good
Thank you, thank you. But despite the fact that I'm a good teacher, you also a very good audience. You are very good audience. Niliwaambia hii ni A. Hii this time ikikosa A ni A minus, minimum B plus. So we
Amen.
keep the hope. Yeah, amen. So we continue. Good. I was looking for question 31 all through. I love question 31 because it shows some concepts which we have discussed using theory concept. But see hatujaifanya practically. So mostly in an exam, the most difficult thing to do is to convert the theory which you have learned in class into a practical. That is why I usually recommend to students, do a million questions. Do as many questions as possible. Because when you are exposed to many questions, unaenda unapata a concept that has been tested in a completely different manner venye hauku expect. Lakini ukienda urevise useme umesoma, utaingia kwa exam room upate venye hiyo swali imetestiwa, ni rahisi ulikuwa unafaa kupata lakini hukupata. So let's do question 31 and then you'll see how a concept, a very small concept, can be actually magnified in a question. Question 31. In an experiment to investigate on aspects of digestion, 2 test tubes A and B were set up as shown below. In setup A, tuko na starch na saliva. Now when you look at this question, don't just look at saliva. Look at saliva from the angle ya saliva iko na enzyme. Na ile enzyme yenye inapatikana kwa saliva inaitwa salivary amylase ama tialine. You remember that name? And we said
Yes.
salivary amylase or tialine breaks down starch into maltose. Si ndio tulisema? It breaks down starch into maltose. So have that concept in mind. Haya, tuende kwa test tube B. Kwa test tube B wamesema inside that test tube there is boiled saliva. There is boiled saliva. Hii saliva ikichemshwa, what have we exposed the saliva through? What tume-expose saliva kwa nini? What has
Saliva
been done to the saliva?
The enzyme ptyalin has been denatured.
It has been destroyed by the excessive temperature yenye iliboil nini? Iliboil saliva, isn't it? So therefore, boiling the saliva means the enzyme salivary amylase has been destroyed. Alafu tumeiweka kwenye kuko na starch. Between A and B, if the test tubes were left for 30 minutes and the content of each test tube was tested, where do you think you're going to find starch after 30 minutes? Test tube A tukirudi tutapata starch?
No.
Hatutapata starch. That is correct. Mbona hatutapata starch?
Because saliva has the enzyme amylase which digests starch.
It will digest the starch into maltose. So tukiangalia kwa hiyo test tube hatutapata starch, tutapata nini? Maltose. Si ndio Catherine na Monica? See, that is true.
Yes, yes.
Yes, good. Haya, tuende kwa setup B. Kwa setup B tuliweka saliva tumechemsha, meaning we destroyed salivary amylase. Sasa tumebaki na boiled saliva ikiwa na starch. So after that minutes tukiangalia for starch, are we going to find starch in test tube B?
Yes.
Yes, we will. kwa sababu boiling the saliva denatures the starch. I mean, not the starch, salivary
And
amylase. So the starch in
Yes.
that test tube will not be digested at all. Even if we wait for 100 years, it will still remain the same. Kwa sababu there will be no digestion of starch since the salivary amylase had been denatured.
destroyed.
Good. See, that is that.
Yes.
So what would be the result expected in test tube A? You say in test tube A there will be no starch, and in test tube B starch will be present because boiled saliva destroyed the salivary amylase. So the account for the results ni kusema explain hizo results. So like for example, what was the aim of the experiment? The aim of the experiment was to investigate the effects of temperature on enzymes. Si ndio? Na remember
Yes.
pale kwa properties of enzymes tulisema they are affected by extreme pH. Haya, kwa exam ingine wanaweza kosa kutumia boiled saliva, but wataandika starch plus saliva the way wameandika kwa A. Kwa B waseme saliva plus starch plus HCl. Saliva plus starch plus HCl. HCl ni acid, hydrochloric acid, isn't it? What will the HCl do to the salivary amylase in the saliva? Again, just like temperature, it will
It will destroy the
denature.
enzyme.
Yes, or it will destroy it or kill it or denature it, isn't it? So
Yes.
therefore, if you test for starch, the result will still be the same, isn't it? Yes, it will be negative. So ukiambiwa explain, unasema the salivary amylase was denatured by VHCl. Therefore,
Starch will be
starch,
present.
yes, will be present because it was not digested. Very good. Question 32 we can also do. Below is the process that takes place along the mammalian digestive system. Tuko na lipids, inapitia process A, inakuwa fatty acids plus glycerol. Aka kenye kamepatika katika hapo, that should be glycerol, okay? So lipids zikipitia process A, zinakuwa fatty acids and glycerol. Fatty acids and glycerol zikipitia process B, zinakombiniwa zote zinakuwa lipids. So which two processes are those? Process A unaona ni kama ni nini? Let's have Domitila. Process A ni nini?
Emulsification.
Emulsification, or it can be the other name which we can use of breaking down lipids. Yes, that process of breaking down. Tulikuwa tunaipea jina gani?
Nimesahau hiyo ingine.
Sawa. Monica, do you want to assist? Ni jina gani tulikuwa tunapea process ya break down a complex food substance into a simpler food substance?
Teacher, asubuhi sikuwa nimeattend, but I'm just listening now.
Oh, you listening? Okay, good. We can say emulsification and we can also say hydrolysis. Kwa sababu hii lipid imekuwa broken down to fatty acids and glycerol. You get it?
Yes.
So it can also be hydrolysis. Sasa ndio process B ikuwe nini? Unachukua fatty acids and glycerol unazicombine, itakuwa
condensation.
Yes, sasa nayo itakuwa condensation, isn't it?
Yes.
So ukiulizwa name the part of the yes?
You say process A is?
It can either be process A can either be hydrolysis or it can be emulsification. Emulsification is breaking down of complex lipids into fatty acids and glycerol. Sawa?
Okay.
Yes. So it can be hydrolysis or emulsification. Let me type for you. Wacha niwataipie jina emulsification hapa. Emulsification. Ndio hiyo emulsification. So emulsification is the word. So it can be emulsification, which is breaking down of complex lipids into simpler fatty acids and glycerol. It can also be hydrolysis. So name the part in the alimentary canal where these processes take place. Hizi process zote huwa zina take place mahali kunaitwa duodenum. We are going to look at the duodenum when we'll be discussing the digestive system of a human being, okay? Yes, so we look for another question. Hii ni nyinyi munanionyesha. Question 37. The table below shows 3 enzymes, A, B, and C, and their respective optimum pH. Let's do this, See we save that question for another time sababu tutafanya factors affecting enzyme reaction. Tutarudi kufanya hiyo swali, okay? Let's do question 38. 38 iko straightforward. Juu ni kama repetition, si ndio? In an experiment to investigate an aspect of digestion, 2 tubes A and B were set up as shown in the diagram below. So kuko na starch plus, I'm sure that should have been salivary amylase, isn't it? And then in test tube B, kuko na starch plus boiled amylase. Si ndio? So in A, are we going to, okay, tusome swali. The test tubes were left in the water bath for 30 minutes and later the content of each test tube was tested for starch using iodine solution. So question A, what was the aim of the experiment? Aim hiyo experiment ni gani?
To test the factors affecting enzymes.
Yes, now which factor is it exactly?
Temperature.
Temperature. So the answer should be to investigate the effect of temperature. To investigate the effect of temperatures on enzyme activity. Sawa sawa. To investigate the effects of temperatures on enzyme activity. Good. Question 2. The next question inasema, explain the expected results in test tube A and B. In A, when we test for starch, will we find starch?
No.
Tumesema hapo kuko na starch na tuko na salivary amylase yenye haijaboiliwa, si ndio? So when we test for starch, tutapata starch hapo?
Hapana.
Haya, tukienda kwa test tube B. When we test for starch, will we find starch?
Yes, present. Starch present.
Yeah, it will be present because the starch will not be digested kwa sababu tulisema boiled saliva has no salivary amylase, isn't it? Then hiyo ni answer. Ukiambiwa state the aim of the experiment ama explain the expected results, kuna maswali inasemanga state. Ukiambiwa state, you'll just say in test tube A there will be no starch, it will test negative, while in test tube B starch will test positive. And then hapo chini wanasema account for ama explain. So ukiambiwa explain, of course explaining has more points, so you are supposed to state what happens and why. So like for example, you would say in test tube A, starch will be absent because salivary amylase will break down the starch into maltose. In test tube B, starch will be present because boiled saliva ama boiling saliva denatures salivary amylase, hence there is no breakdown of starch into maltose. So that is well understood?
Yes.
Good. Tufanya question 39. Najua question 39 tulifanya hapo nyuma kidogo, but it is also on nutrition. So name the specific part of the chloroplast where the following processes occur. Remember tulisema photosynthesis ina take place na 2 stages, isn't it? Kuko na photolysis na kuko na carbon dioxide fixation. That is the light stage and the dark stage. So carbon dioxide fixation ni dark stage ama ni light stage?
Dark stage.
It is the dark stage.
Yeah.
Good.
Yes.
Photolysis ni light stage, isn't it? So carbon dioxide fixation ina take place wapi?
Ina takes place in the dark stage.
Dark stage ina take place wapi? Swali inasema the specific part of the chloroplast.
Okay.
Tulisema kuna parts mbili za chloroplast. Kuna? Yes? Starts with letter S.
Stomata.
Stomata is an opening that allows air in and out, so it cannot be the stomata. Starts with letter ST. ST. Kuko na
Stoma.
granum na kuko na stroma, isn't it? So dark stage ina
Stroma.
take place kwa stroma, light stage ama photolysis ina take place wapi?
The granum.
Granum.
Kwa granum, kwa sababu granum iko na nini? What did we say is found in the granum?
Iko na chlorophyll.
Very good. Iko na chlorophyll, the one that traps sunlight for photosynthesis, isn't it?
Yes.
Yes, good. Is there any question? Yes, there is. Question 47. Question 47. State two differences between monosaccharides and polysaccharides. State two differences between. So hapa ukiambiwa state two differences between monosaccharides and polysaccharides, unafaa kuongelelea kuhusu characteristics or properties. Unakumbuka zile properties tulisema, one is sweet tasting, it is soluble in water, ingine tukasema they are yes, those ones, those are the differences you're supposed to give. So hapa unaambiwa state two differences between monosaccharides and polysaccharides. Now I will state the characteristic and you'll tell me which one is on which one is not. Okay, let's talk about solubility between monosaccharides and polysaccharides. Which ones are soluble?
Both are soluble.
Both are
But
soluble.
both are soluble.
No. Monosaccharides.
Examples ya polysaccharide ni kama gani? Tulisema ukisikia polysaccharide unakumbuka, so turudie kidogo let's rewind Tulisema carbohydrates are divided into 3. Kuna monosaccharide, kuna disaccharide na polysaccharide. The simplest form is a monosaccharide. So are monosaccharides soluble in water? Example ni glucose.
They are soluble.
Good. Haya, the second type of a of a carbohydrate ni disaccharide. Na example ya disaccharide ni maltose na lactose. Are they soluble in water?
No, they are insoluble.
Disaccharide. Disaccharides are soluble, isn't it? And then we have the third type of carbohydrate, which is polysaccharides. So are polysaccharides soluble? Example ya polysaccharide ni starch, kama yenye iko kwa mahindi na mchele. Are they soluble?
No, they are insoluble.
They are insoluble. And ndio maana hujaienda kupika mchele ukapata yote ili dissolve. They are insoluble, isn't it? So solubility between monosaccharides and polysaccharides, which ones are soluble?
Monosaccharides are soluble.
So you say in an exam, monosaccharides are soluble while polysaccharides are insoluble. Sawa? Which ones are sweet tasting? Monosaccharides, which are glucose, ama polysaccharides, which is rice and maize?
Monosaccharides are sweet tasting.
Sweet tasting. Now, can I give you the secret to understanding this concept and knowing the difference?
Yes.
Make sure you know an example of a monosaccharide. Make sure you know an example of disaccharides, and make sure you know examples of polysaccharides. Before you know those examples, it will always be a problem. Kwa sababu kwa swali kama hii, ukiambiwa between monosaccharides and polysaccharides, if you knew the examples, the first thing should have been glucose is a monosaccharide. So una relate, glucose nikiweka kwa maji itadissolve? Itadissolve. Itakuwa tamu? Itakuwa tamu. Polysaccharide ni nini? Ni maize. So maize haitakuwa soluble na it is not sweet tasting. Si already ushapata differences zako mbili?
Yes, so the secret disaccharide nini yake?
Disaccharides tulisema disaccharides ni kama tulisema ni kama kuko na lactose. Lactose ndio iko kwa maziwa, isn't it? Tukasema kuko na maltose na kuko na sucrose kama ile iko kwa miwa. Juice sucrose, isn't it? Na sasa sucrose ukiweza chukua hiyo ya miwa, kwanza ukikula miwa inakuwa tamu. So ukisikianga disaccharides, kwa unakumbuka miwa, sucrose. disaccharide, miwa, sucrose. So unajiuliza miwa ni tamu ama si tamu? Ni tamu. So unasema
They are sweet
disaccharides are
tasting.
sweet tasting.
Tasting.
And of course
And
they
they
are
also
soluble
come
in
water.
isn't it? So
Yes.
kwa monosaccharides shika glucose. Kwa disaccharides shika sucrose ya miwa. And then kwa polysaccharides shika mahindi ama mchele. So every time unaambiwa distinguish between either, utakuwa unajiuliza mahindi ni polysaccharide. Is it soluble in water? No, it is not. Is it sweet tasting? No, it is not. Then unaenda kwa disaccharide. Sucrose. Sucrose iko kwa miwa. Miwa ni tamu? Yes, it is sweet tasting. Is it soluble in water like ile juice ya miwa? Si miwa the juice, because it is the juice we are talking about. Hiyo juice ya miwa ni soluble in water? Yes, it is soluble. So unaenda kwa monosaccharides. Glucose nikiweka kwa maji itadissolve? Yes, itadissolve. Nikiweka kwa ama nikitest ni tamu? Yes, it is sweet tasting. Yes. So those are the ways in which you can be able to tell the difference between or among the three. Sawa sawa. And the last question, question 47B. Ona niliwaambia you can get a question asking you to name the bond found in proteins. Nani nakumbuka the bond found in proteins? Liko inaitwa aje?
Peptide.
Yes, the answer is correct. It is peptide bond. Peptide bond, okay? Na ya carbohydrates, tumalize na ya carbohydrates. Starts with G.
Glycosidic bond.
Yes, glycosidic. Good. Glycosidic, that's very good. And the last one. Bond ya ilikuwa ya nini? Bond ya lipids. Yes, ya lipids.
Ester
Ndio
bond.
tumefanya ya mwisho.
Ester bond.
Ester bond, isn't it? Yes.
Yes.
So far so good. Hiyo concept ya chemical compounds of life I feel tumeishika vizuri, si ndio? Na hiyo ya enzymes, eh?
Yes.
So tomorrow, God willing, because we are going to have biology like usual, tutaongelelea factors affecting enzyme activity, alafu tutafanya maswali ya factors affecting enzyme activity. Ndio every time ukienda kwa exam room ama ukifanya exam upatana na hiyo swali, it will always be easier. So this is the method that I like. You do a concept, you do several questions. You do a concept, you do several questions. That way you will know how questions can be set and you will hardly forget that concept. See, that is okay, it's in order.
Yes.
Okay, so if it is in order, thank you for showing up. That marks the end of the lesson. I'm very happy and I wish you all the very best and have yourselves a good night. See you tomorrow, God willing.
Thank
Good
you,
night,
teacher.
Mwalimu.
Have a good night.
Thank you.
Okay.